Let's move into the fifth and final piece of this series. So this is what I'm calling sort of next generation workloads. So this is specifically machine learning and AI. So something that's very fascinating, and before we jump in, I just want to step back and say this is sort of as it relates to a data fabric. So we're talking about how Pulsar can be the data fabric for enterprises and companies in the future. And next generation workloads just have to be talked about. So a lot of the sort of pressure or interest investment that's happening around data management is all because that's what feeds, data-driven decisions, obviously. And machine learning, the more data you have, typically the better. So there's this huge push for data accessibility. How do we manage our data? How do we make sure it's accessible? Not just in its sort of final form, but in its raw form. And how do we provide an audit trail of what happens to that data? If fields are dropped, if fields are changed, we need to know who changed it, why they changed it, and things of that nature. Because you'll find a lot of times the raw data may create patterns with machine learning that you might not have assumed. I went through a very specific example myself where we were leveraging review data, and we were using the aggregate score from the review data. So this is like a third-party provider. So it's like the average score that you see on the profile, but then there's hundreds of thousands of individual reviews, and they have their own scores as well. We were finding that the model, when we sort of used the averages, worked great, but when we got access to the raw data, we were able to sort of look at that and filter out reviews, and thus change the sort of score, the average score. Also, we found a lot of times like the owners of the business would be sort of submitting reviews, and there'd be obviously bogus ones or ones that weren't necessarily the fault of the business. That was a large percentage of them. It was still single digits, but it affected the scores quite considerably. It was single digits of the entire sort of data set, but for a very specific business like a plumber who doesn't have a bunch of reviews, that could change it drastically. That could take, if it was on a scale of like 1 to 5, it could take something that was like a 3.1 and make it a 4.4, which is significantly different. So it just sort of creates parity across that, and you get rid of some of the junk reviews and things like that. And that ended up creating a huge boost in productivity. This was specifically around assessing insurance risk. So those sort of 20% bumps are quite significant for the accuracy of the model. So that's just one example of how having access to that raw data can be more valuable than just the aggregate or the final state of the data. But when we sort of look at a future, having your data ready for AI and ML is not such an easy task. Again, we mentioned the Pulsar SQL, so the abstraction layer. Data scientists need sort of easy access to this. They're not sort of experts in Python or R. They're sort of geniuses around the math of doing math against letters is what I kind of describe it the other day, which of course gets converted into numbers, but that's where their expertise should be. I've seen personally where data scientists specifically spend the majority of their time, vast majority, over 90% in data preparation. So this is accessing the data, cleaning the data, turning it into a structured format. You could sort of fudge it, like PHP was a language where it wasn't strictly typed. So you could have a situation where a floating point number was sort of converted to an integer. Wasn't end of the world type scenario, but you do that in data science and you can have massive problems. And that's a very hard thing to sort of detect as well. Imagine where your floating point is between 0 and 1. Well, you cast that as an int, and now you've turned it into a Boolean, and that can be very dangerous, especially if that was a feature in a model that was weighted heavily. So this sort of data quality becomes massively important. And so you want sort of to put the focus on the right things when you do machine learning and AI. And that's where sort of Pulsar can come in and sort of help provide accessibility and connectivity to that data. as well as that sort of lightweight compute framework can do a lot of the sort of joining, extraction, and cleaning and things of that nature, so that when the data scientist issues SQL against that abstraction layer of the data, they're getting back exactly what they want at the end of the day. They may have to do some things to it at the end of the day. They may turn 1 or 2, 3 data points into a new data point, which only they could do, but that's exactly what you want them iterating on. You don't want them iterating on the other things. So, and Pulsar really enables that, makes that a lot easier for them at the end of the day. Additionally, and incredibly important, is the scalability nature of Pulsar. So, when you think of like machine learning and AI, it's very much like traditional software, but it's orders of magnitude more of everything. So it's more data, it's more labor, more CPU, more memory, more hard drive. And it becomes very hard to sort of make all that data accessible. So you imagine if you had petabytes of data and you want to sort of access that mostly in parallel. That scale is incredibly difficult. It's basically a scale that very few companies on the planet have ever had to deal with. And so that sort of requires a stateless or horizontal scaling capability of a system to sort of do that. And some of the software that's out there right now, and I know specifically something like Kafka, a lot of large companies sort of using Kafka and that are sending a lot of data through are having a lot of operational problems with it. A consumer slowing down or doing a sort of catch-up read is slowing down producers and things of that nature. Also, the sort of fact that hard drive and brokers are locked together. There's just a lot of sort of complexity around that. But what's very important about Pulsar is it separates compute and storage, so you can scale them independently. You might have something that's CPU intensive and you need to scale that piece. You might have something that needs other components scaled independently, the memory, hard drive, and things of that nature. It does that incredibly well due to its cloud native nature. That means you can go from sending 1,000 messages a second to millions with ease, hundreds of millions, billions. That software, Pulsar specifically, is able to scale to absolutely absurd levels with very little sort of hardware behind it. And it does it in a sort of not operationally complex sort of way. And those are really critical to machine learning and AI, where you've got you need to feed data into something like Spark at insane speeds so that you can complete your training as fast as possible to get your model into production as fast as possible. So you want something that scales incredibly well as handles some of the connectivity and accessibility for you to get that data into Spark with as few systems as possible and as few sort of humans as possible and as little code as possible. Pulsar is just fantastic at that. So to me, the last piece of Pulsar here that we're going to talk about, this 5th series piece, is how Pulsar, compared to anything on the market, I've tried it all, is the best solution for today's workloads. Because again, big data, it's a hard term because it's sort of like a moving target. Big data is not the same thing it was 2 years ago or even 1 year ago. It's almost like big data or huge data now, but it's only growing exponentially. And Pulsar is really the only thing today that handles that scale without breaking a sweat. Everything else, the throughput starts to go down, latency, you start to lose messages. You have to spend too much to keep it going, so now your ROI is sort of getting out of whack and you can't even really calculate it anymore. But Pulsar, for me, is sort of the shoe-in for these types of workloads. And if you imagine we believe, and I believe, Pandio believes, is every company is going to need access to machine learning and AI. So something like a data fabric that we're talking about here today is going to be needed by everybody. And the fact that Pulsar, out of the box, can basically give you a data fabric, and the only thing you then have to deal with is sort of the adoption of it internally. It's something that every company needs to be exploring, and it should be on the roadmap In my opinion, in the next year, 2021, but definitely by the end of 2022, some major component of an enterprise will be a data fabric. And since Pulsar is that today, it's a natural shoe-in. I appreciate you checking out this series. We'll be doing more in the future, dive in more specifically, but that's it for now. Thank you.